48. Let's go to 48. 48 says when a known standard resistor of 2 ohms is connected to 0.0 cm end of a meter bridge, the balance point is found to be 55 cm. What is the value of the unknown resistor? So there's a known standard resistor and there's an unknown resistor. So what we're looking for is the unknown resistor. So let the unknown resistor be X. Alright, so what we are going to do here is simple. We're going to say R, that is resistor, over X is equals to the length. The length is 55 over 100 minus L minus the length. So this is the formula to solve that. This is a formula to solve that. Alright, so straight, no time. We're going to 53 now. Yes, 53. 53 says 53 says a moving coil galvanometer of 3 ohms gives full scale deflection for 1.0 mA, that's milliampere. The resistance R of the shunt that is required to convert the galvanometer into a 3.0 A ammeter is what? So we're looking for the external resistance. That we're looking for the external resistance. What we're looking for. External resistance is what we are looking for, or the resistance of the shunt. The resistance of the shunt, that's RS that we're looking for. So 53, the formula to solve 53 is R shunt, that's R shunt is equals to what? The current of the G, that's current of the galvanometer. Current of the galvanometer is what? Is 1.0 milliampere. Then we multiply that by the resistance of the galvanometer, which is what? Which is 300 ohms over I again. What's the I? What's the I? I is the current we want to convert in the galvanometer, which is 3.0 amps. 3.0 amps minus the galvanometer's current again. That is that one. Now, this is the formula. This is what you are imputing. This is the formula you are using. But this 1.0 milliampere, you are going to change it to ampere because there is an ampere in ampere. That there is a current in ampere. So you are going to change everything to 1. That's you are going to change the milliampere to ampere. So what you are going to do is 1.0 all over 1000. So you're supposed to get something around 0.001. So this is your new Ig. This is your new Ig. So you put this 0.001 here and put 0.001 here. What I'm going to put in this ROG now, you're going to put 300 ohms here and you're going to put 3 here. So that's what you do, and then you solve. All right, okay, that's that for that. We're now going to 55. So 55 says a wire of length 15 meters made of a material of resistivity 1.8 times 10 raised to the power of minus 6 ohms and has a resistance of 0.7 ohms. 0.7 ohms. Okay, let's look for the other part of the question. Okay, so we've gotten the other part of the question. It says determine the area of the wire. So we're looking for A. So this is 55. We're looking for A. So what we're going to do is R. This is the formula we're supposed to use. We're supposed to say R is equals to P is resistivity, then L is length, and A is area. But now we're looking for area, so we'll make area the sort of formula. We make area the sort of formula is just to bring out the A, replace it with P is equals to PL over R. So you put L in length, you put resistor in R and then you put resistivity in P, and this is your formula to solve for that question, for question 55. This is the question to use. This is the formula to use to solve for that question.